I'm Georgina.
And I'm Rachel.
And this is our Ecocolumn project presentation.
So our Ecocolumn presentation will be about our Ecocolumn experiment and which questions arose from that. Also, what data we took from our experiment and what the trends suggest. Additionally, we will talk about our question that we are choosing to study to further our knowledge of ecocolumns and how we propose to do that. So our ecocolumn we named Mars. It has 1 aquatic plant and 2 terrestrial plants and 2 currently decaying fish. We named them Marvin and Ricky. And the water used to be clear, but now it's kind of murky because, you know, things are dead.
So, ecocolumn monitoring. In our ecocolumn, we measured 3 factors, which is dissolved oxygen in the aquatic chamber, pH levels in our aquatic chamber again, and the oxygen, which is in our terrestrial chamber. We measured the dissolved oxygen from the aquatic chamber to monitor any declines in the ecocolumn. The dangers of more oxygen being consumed than produced can cause the animals to weaken or die or suffer, which isn't good. The pH levels, we measured it because in our aquatic chamber, the acidity of the chamber should not be too acidic or too basic. If the water becomes too acidic or basic, it can cause damage to the organisms residing inside the ecocolumn. We measured the oxygen because it's used by all the organisms inside the ecocolumn. If a decline in oxygen occurs, all living things would soon die, pretty much.
So our ecocolumn data for the dissolved oxygen in the aquatic chamber is on day 0, it's 7.48 milligrams per liter, and on day 1, it's 1.20 milligrams per liter. On day 2, it's 2.25 milligrams per liter. On day 3, it's 2.6 milligrams per liter. On day 4, it's 4.73 milligrams per liter. And on day 5, it's 3.40 milligrams per liter. So as you can see from our data, the dissolved oxygen declined drastically between day 0 and day 1. And it continued to decline the entire time, except on day 4 where it rose, but then it declined again on day 5. And then for our ecocolumn data for the pH levels in the aquatic chamber, on day 0 it's 6.52, on day 1 it's 6.4, day 2 it's 6.3, day 3 it's 5.7, day 4 it's 6.91, and day 5 it's 6.2. And so there are similar trends as there was in the dissolved oxygen levels in the aquatic chamber. The water becomes more basic between days 0 and 3, and then it becomes very acidic on day 4, which means it, rose quite sharply, or it fell sharply. But then it rose again on day 4 and again declined on day 5. So our ecocolumn data for the oxygen in the terrestrial chamber is that on day 0, there's 21.11% oxygen. On day 1, it's 20.43%. On day 2, it's 20.17%. On day 3, it's 19.83%. On day 4, it's 20.13%. And on day 5, it's 20.08%. So the dissolved oxygen, like the pH levels and the dissolved oxygen in the aquatic chamber, falls after day 0, but rises again on day 4, but then it declines on day 5.
So the question posed is, did the decline in oxygen in the aquatic chamber cause a decline in oxygen in the terrestrial chamber? Or, also, why is the water becoming more acidic than basic? Why is the oxygen decreasing, and what has happened between day 0 and day 1 to make the oxygen decline?
And so our proposal for future study, the question we chose to examine is, how did the death and decomposition of fish in the aquatic chamber negatively impact the nitrogen levels in the soil of the terrestrial chamber? And we chose this because we figured the only thing that happened between day 0 and day 1 was that our fish died. And so to refine this question, we specified where the measurements would take place in the aquatic chamber and in the terrestrial chamber. And we defined how the fish should impact the other chambers, that is, negatively.
Our proposed hypothesis is that if we increase the number of dead fish in the aquatic chamber, then the amount of nitrogen in the soil of the terrestrial chamber would increase.
And so our proposed study design, we have the independent variable as the number of dead fish. The dependent variable is the amount of nitrogen in the soil. And for our control group, we have an eco-column with 0 fish. So the materials we would need to conduct this study is 1 nitrogen test kit, 4 eco-columns, and 6 dead fish, all of the same kind, of course.
The method was step 1, build 4 eco-columns. Step 2, label eco-columns, 1, a control fish, and 2, no fish. Step 3, fill eco-columns with 2 dead fish, and fill eco-columns 2 with 1 dead fish, and step 4 would be fill eco-column with 3, no.
Eco-column 3.
Oh my gosh. Okay. Fill eco-column 3 with 2 dead fish. Step 5, fill eco-column 4 with 3 dead fish. Step 6, seal eco-columns. Step 7, leave eco-columns for 24 hours. Step 8, measure the amount of nitrogen in the soil of the terrestrial chambers of eco-columns 1, 2, 3, and 4 using a nitrate test kit provided by the lovely Mr. Carr. Step 9, record nitrogen amounts for day 1. Step 10, record observations as to how much of the fish has decayed. And step 11, repeat steps 6 through 10 4 times.
And so we would like to thank and acknowledge the Everest Apes for funding our eco-column research.
And thank you to the NSF for considering this proposal. And thanks, Rachel, for helping me when I get confused.
And thank you, Georgina, for all the crucial help you've given me.
Thank you, Mom. I love you. Alright, dude.
Okay.
This is Joe.
Okay, cool. We definitely had like longer than like 7 minutes.